Greetings everyone, this is Non-Expert here back again with another video. Recently we completed our third day LeetCode challenge for the month of April, and LeetCode has issued a new challenge for the month of May where it's going to do the same exact thing which it did for the April month, and it's going to publish a problem every single day. Now, I'm not too sure whether I'm going to be publishing every single day for this month, but the problem which has been given today is actually really interesting. I've seen this problem being asked in Facebook and Amazon interviews, so I thought it would be a good problem to tackle. So the problem which has been given to us today is the first bad version problem. If you want to try solving this problem on your own, you can pause this video and check out the LeetCode link given in the description below. And let's get started. So you're a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version and all the versions after a bad versions are also bad, you need to find out where it exactly started to fail. So suppose you have n versions, which is 1 to n, and you want to find out the first bad one, which causes all the following ones to be bad. And you've been given an API which takes in a version number as the parameter, and the name of the API is basically a function is bad version, and it returns a boolean value and returns whether this particular version that has been passed in as an argument is bad or not. So we need to implement a function to find the first bad version, and we need to minimize the number of calls to the API. So this is a pretty straightforward problem, and you can see this example which has been given over here, which is given n is equal to 5 and the version is equal to 4, and basically version equal to 4 is the first bad version. You need to somehow find out this particular 4. So if you start with 3, you're going to get an output of false, which means that it's not a bad version, which means that it is a good version. Then you sort of go to 5, which is a bad version, so it returns a true, and then you sort of eventually go to 4, which returns a true. So in this example itself, they've sort of given you a hint, and you can see the trend which is being followed over here is more like a binary search trend, and that's the intuition that you should have when you're solving this problem as well. So again, you have a sorted list, you want to find out one particular element, and you don't want to use too many calls. So the best operation that you can do in this case is to work with the time complexity of log n. And the way to do that is by using binary search. Now there are various ways of actually solving this problem, and various simple ways. And you can simply call a while loop and do the binary search over there, but we're going to make this problem a little bit more difficult for us. So since we already determined that we're going to be using binary search over here, let's just create a function called as search, which takes in a low and a high, and basically return a pass over here. We also want to make sure that we are not calling the API over and over again. So we're not calling this isBad version function over and over again. So we're also going to maintain something like cache. And the cache is usually a key value representation. So we can sort of maintain that by maintaining a dictionary, which is basically visited, and it's going to be an empty dictionary. And if we pass in some value, we don't really need to pass through it again. So that's the basic idea behind this thing. And eventually what you want to do is you want to leverage the search function and return that to your first bad version function. So the iterations are not zero indexed. The first version is going to be 1, and then it's going to go to n, which has been passed over here. And now we sort of talk about our logic. So it's pretty straightforward. There's not really that much into it. So the way you want to think about this thing is, if it's pretty straightforward, simple binary search. So you just say, hey, if low is greater than high, then you return 1 or something, which is basically the first function. Um, and the next thing that you want to do is you just want to find out the mid value. So just do mid high of 2. So basically the average between low and high. So that's your present mid, and let's save that somewhere inside of variables. Let's call that present mid, and let's call this isBad version function and pass in the mid. So inside present mid, we actually have a value which we really need. So the breakaway condition would be if we have something which is if this particular guy, the present mid, is actually true, which means it's a bad version, if the previous version to this was actually a good version, well, in that case, we found a bad version. So that's something that we need to just look at. So we can just say, hey, if present mid is returning true, and do remember that if it's returning true is basically is bad version is returning true, which means that this particular version is actually bad. And if that's the case, we can also check for if the previous version to this was actually good, which would be not of this thing. Well, in that case, you can basically return mid. You have a few other conditions which are basic small conditions that you can think about. If you presently are on a mid, if your present mid is actually true, then that will mean that whatever bad version that you have is going to be at the right side of your array if you split it. So if this is your mid, all the left side, if this guy is actually true, then everything before this is a good version and the bad version has to be on the right. So that's something we can take care of. So that's a pretty simple condition. You can just say, hey, if not present mid, which means that if it is true, then you return search and you recurse to mid plus 1 of high. Otherwise, you know for a fact that's going to reside inside the left side of your array, so you're just going to put low mid minus 1. And this entire code will work fine, but we want to make this a little bit more complicated. So all we've done over here is just done a simple binary search. So if you have, let's just give a comment over here, and I'm just going to say good of good of good of good, and you have a bad over here. So when you have this, this logic running through, you're going to have this mid value, and this is going to be a good value, so you know that the bad is going to be on the right. So this is the this is the condition that's going to fall through. It's going to have mid plus 1 and high, so you're going to look at this right subarray. If the value was somewhere over here, then it would have gone to the left subarray. So simple binary search operations. And now we're doing an additional column is bad version, which we really don't need. So what we can do is we can call visited of mid. So basically whatever value that we've given as a version, you save that inside our dictionary, which is visited mid, and save the value which it had returned. So then we can sort of remove this callback, and we can call this thing as if mid minus 1 was inside visited, and also it returned a not in this case, so this would be not visited mid minus 1. So this entire representation over here is talking about whether the value which we've stored before the present mid, if there's a value which is stored over there, and the values before this was actually returning a good value, in that case this present mid is actually the version which was actually bad. Similarly, we can also look for the next version beside present mid. So if present mid is actually returning a false, which means that it is a good value, so in that case we can look for the next value if we have that stored. So we can say, hey, if we have the next value already stored inside our dictionary or our cache and it returned a true, well, in that case that guy is something that we are looking for, and we just need to return mid plus 1. And that's basically it. So you've incorporated a caching logic inside your own code. You've minimized the number of calls, and you've used the simple binary search to optimize your operations to log of n. So let's just go ahead and run this, and hopefully this should run fine. And you can see it's running fine, and let's just go ahead and submit this, and hopefully this should get submitted as well. And awesome, you can see that the solution's been accepted. And there's not really that much to this problem, to be honest with you. You can solve this in a very layman term manner, and just have to call a simple binary search and you'll be good to go. But just to minimize and optimize your problem even more, because in an interview what's going to happen is that you might have the interviewer ask you, okay, you're making a few more calls, how about you reduce them? And caching would be the best approach to go over there. Cool. So if you have any doubts or if you have any comments, do leave it in the comment section below. I'll try to get back to you as soon as I can. And if you did like this video, do give a like and do subscribe to our channel. We are a discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.